In the previous lecture, we discussed how you can develop a vector as well as how you can do some subsetting based on certain selection vectors that you can define using true or false values, and how you can use certain conditions to subset vectors. Here we will do some functional aspect of programming in R with vectors. So we'll discuss how we can do arithmetics with vectors. And why I call those functional understanding of working with vectors is because everything in R is a function. So when you talk about functional programming paradigm, R supports both of those paradigms where everything is an object as well as being a function. So we're going to be working with the addition, subtraction, multiplication, division, those sorts of functions in a moment. So let me add a comment. And the way that you add a comment is you put a hash and then you say whatever you want to comment out. I'm going to write the description of what we did here. So we did subsetting the grades vector. And on the bottom, I'm going to create more. And I'm just going to get rid of all these other comments. It's getting in the way. So let's enter a space and let's work with some mathematical functions here. So we'll do mathematical functions. So we'll define a couple of vectors and we'll take the sum of those vectors. Say we had a grades vector here as well. Now, the way that the grading system in America works is you can have, say, 4 of these grades and there's going to be 4 tests, say, in the whole year. And if you're going to say grades 1, grades 2, grades 3, and the element 1 corresponds to student 1, element 2 corresponds to student 2, element 3 corresponds to student 3. If you take a sum of all of these, you'll get the summation of all of the grades that the student has received in the 4 tests. So if we just change this around a little bit, make it 94, make this a 78, change a couple of these around, 98. Okay, we've done some changes to our grades, and if we take a sum of all of these grades, we can have a summation vector. So we'll have sum underscore vector, and we'll hold the sum of all of these. So we'll do grades 1 plus grades 2 plus grades 3 plus grades 4. And if we print out our sum vector, and let's load all of these first. Okay, we can see that the sum vector most likely holds the values of all those 3 test scores. Now, if you were thinking that the addition is actually going to do a concatenation, you're slightly off, because here, when we do addition between vectors, it works as a simple element by element addition. So you do 98 plus 94 plus 97 plus 98, and it's going to do element by element addition. So it's going to match up the first element of this vector, first element of this vector to the first element of this vector, so on and so on. If you want to do concatenation, we've actually seen how we can do concatenation, and that is right here and in every single vector definition which is more than one length long. So we've actually concatenated the vector which holds 98, the one element vector, and we've concatenated it with these other vectors. And you can do the same here. You can say C, and you can put grades 1, comma grades 2, comma grades 3, those sorts of things. So let's do a division of this by 4 so that we can see what the grade point averages of these people are. So it's 96.5, 97, so on and so on. Now to factor in the other variables as well, we can see how well the grades 1 predicts the overall average. So say we do 98, and then we're going to do a subtraction of that from the sum vector divided by 4. So basically what we have is we have some sort of a means vector here, and that means vector is assigned to sum vector. So we're going to do a subtraction of the grades 1 from the means vector. We'll do means underscore vector minus grades 1, and let's do a highlighting and running of that, and you can see that the prediction is actually not too far off for most cases. For the first case, it's only 1.5% off. For the second case, it's exactly spot on. Second to last case, it's also exactly spot on. And here there has been a couple of improvements. There has been a negative progress here. There's positive progress here and negative progress here. So that's the way that you would be using some of these mathematical functions. And you'll see these everywhere in R programming. And these are used as much as the other functions such as length, sort, and some functions we'll be taking a look at in the next lecture.